So this one is a system quality considerations. These two functional requirements is basic need. It simply says a functional, it means what RFID does, like tag reading, tracking and authentication. Then comes to a non-functional. Here it tells about how well it does it. That means it is fast or secure or reliable or scalable, like that. So I explain the first one is functional requirements of RFID, right? So it has some core operations like tag reading, writing, unique identification, data transmission, multiple tag reading, integration with applications, event management, access control and authentications. So these functions are included in functional requirements. Then comes to a non-functional requirements of RFID. Here the how the systems is performance, like, so it's full and full deals about the quality attributes like performance. In performance, in sense, it's based on their speed and latency, right? The second one is accuracy. The third one is reliability. And the fourth one is security and privacy. Next one is scalability and interoperability. Then comes to maintainability and then cost effectiveness and user friendliness. This is the most important topic in RFID, that is confluence of technology. So RFID technology is the result of confluence of several advanced technology, especially in the field of semiconductors. So at the core of every RFID system lies the RFID tag, which is built using semiconductor microchips. So these chips combined multiple technologies like microelectronics, wireless communication, data storage and processing, and power management, and integration with IoT and sensors. For example, integration with IoT and sensor, here that semiconductor technology supports RFID chips with added sensor functions like temperature or pressure. It enabling them to work in smart environments and IoT, right? So RFID is not just about radio waves, it is the coming together of semiconductor microchips, wireless communication, data storage and power management technology. So this confluence has made RFID more powerful, affordable and widely usable in supply chain, healthcare, transportation and security. This is the second one, that is an intelligent devices. So in intelligent devices, RFID represent the blending of multiple advanced technology into one system. So modern semiconductor design enables tiny microchips that store and process the data inside the RFID tag. So wireless communication technology allow these tags to interact with readers without physical contact. So power management circuits harvest the energy from radio waves, so making passive RFID tag battery free and long lasting. When combined with a sensor like temperature or pressure or motion, RFID tag becomes smart devices that can capture real environmental data. So integration with the IoT, cloud computing and AI further enhance their intelligence, enabling devices to track, analyze and make decisions automatically. So it makes RFIDs an essential part of IoT devices used in smart homes, healthcare, logistics and industry. RFID in broadband, wired and wireless technology. So the development of RFID has been supported by the convergence of broadband, wired and wireless communication technologies. So wired broadband networks such as fiber optics and high-speed Ethernet, it provides the backbone of infrastructure for transferring large volumes of RFID generated data to enterprise servers and cloud platforms. So wireless broadband systems like Wi-Fi, 4G or 5G and any satellite communication, it just enable mobile RFID readers and intelligent devices to transmit the data in real time without physical connections. So this confluence allows RFID to function seamlessly in applications that require instant connectivity, such as global supply chain management, smart transportation, healthcare monitoring, and retail automations. For example, RFID tag collect item data wirelessly, broadband transmits it from readers on the move, and wired broadband carries it securely to centralized database for then analysis, right? By merging RFID with broadband wired and wireless system, so industry achieve faster data sharing, higher accuracy and real-time decision making. The fourth one is edge processing. Uh, Here, this is an model diagram for enterprises edge along with an internet. It can connect with that kind of electronic devices. Then comes to an IoT things also. These are all processed and enabled from the data center. So RFID technology, when combined with edge processing, it creates a faster and smarter intelligent system, right? Normally RFID readers collect data from tags and send it to a central server for processing. However, with edge processing, much of the computation happens locally at the RFID reader or nearby edge devices instead of the distant cloud. The last one is RFID in service oriented architecture. So SOA, it's a software design approach where different services like authentication, data processing and inventory updates, etc. So these are loosely coupled and communicate through standardized interfaces. RFID fits naturally into SOA because it generates continuous streams of identification and tracking data that can be used by different services across the industry. So RFID as a data source services, then middleware integration, it act like a service layer. The third one is interoperability. Here it can be shared across multiple systems. And fourth one is real-time business process. For example, when an RFID tag on a pallet is scanned at a warehouse gate, so that RFID service is automatically triggers related services such as updating stock in ERP systems and generating invoices, like that. Final one is scalability and flexibility. So with SOA, RFID can be easily integrated into new applications without redesigning the whole systems. So it makes it more adaptable for retail, healthcare, transport and defenses. So in SOA, RFID is treated as a service provider for real-time data, and other business applications act as a service consumer. So this makes systems more flexible, scalable and efficient in handling RFID information across different domains.